All right. So the first problem we run across here, the first thing we're going to run across is something not too crazy. We're going to look at, we're given the function f of x equals 1/3 x cubed minus 4x. We want to find the intervals of increasing, decreasing, concave up, concave down, relative maxima, relative minima, points of inflection. And then use the graph to verify your answer. So again, just kind of checking to see, okay, how these all match up. So, without further ado, let's get into that here. All right. So, let's just start off. So let's try and find those intervals of increasing and decreasing. All right. So Tyler, how do we find intervals of increasing and decreasing? Take the derivative of the function, okay, and then what? So it equals 0. All right. So what is the derivative of this function here, Tyler? Okay, equals x squared minus 4. Well, that's nice. So we got rid of that fraction. Okay, so it equals 0, and so you get x squared equals 4, so x equals plus or minus 2, right? All right, great. So we've got our, and what do we call these two numbers here, by the way, Tyler? Critical points, that's right. We get critical points by setting the derivative equal to 0 or undefined, right? The derivative is not undefined here, so we don't have to worry about that. So just those are critical points. All right, great. All right, at this point, then, Joey, what do we do?
Then we're going to put that on a little number graph.
Put that on a little number graph. Okay. So f prime, and we'll plot -2 and 2. Make sure you put these in numeric order. Okay, if you put them out in numeric order, you're going to mess yourself up. All right, great. And now what, Joey?
We're going to solve for 3 other points, which would be 0.
Okay, so f prime is 0 there in that interval.
And then f prime of -3.
F prime of -3.
F prime of 3.
F prime of 3. Okay, remember, any point in those intervals, all right, you can choose any number, any value. All right, so we plug these then into f prime, right? So if I plug -3 in, Joey, is that going to yield a positive number or a negative number there?
Yeah, it'll get you positive.
Yeah, to get you positive, that's right. Okay, and then 0,
Negative.
negative, and then 3,
Positive.
positive. Okay, yes.
So I found like this one ahead, and like I factored that,
Okay,
and like so you don't get the same.
you factored x minus 2 and x plus, to x minus 2 and x plus 2?
Yeah, but once then you get negative, so it's like there's like negative 2 and negative 3 times.
All right, so let's see that. So x, right, because it should be the same thing, right? So let's see. So you got x minus 2, x plus 2, and you factored it, right?
Yeah.
And then you, so you got the same -2 and 2 for your critical points.
Yeah.
You then chose -3, 0, and 3. Okay? And then when you said you plugged in -3, so let's plug in here. So -3 minus 2, -5, so just negative. And then -3 plus 2, so negative times negative, yeah. So that's okay. That's, I mean, so that's, that you're, I mean, it's good, I mean, that you asked that question, because yes, it should, we want it to be the same thing. So, you know, we want to make sure we're getting it right there. So that's what it is, okay? So, let's see here. All right, Connor, then what are the intervals of increasing and decreasing here?
So the interval of increasing is from negative infinity to -2.
Okay, so f is increasing from negative infinity to -2.
And then u.
Union, to infinity. Okay, and how are you able to tell that? What if we were to justify here? It doesn't say to justify, but if we were to justify, we would write because what?
There are positive numbers in the interval.
So yeah, I would say because f prime is positive on that interval. Okay, because I'll write it here just now that I've written that. I don't want to abbreviate. Because f prime, I'm just going to put is greater than 0 on that interval. Okay, just saying there are positive numbers, we could all, but that doesn't then say there aren't negative numbers. You know what I mean? Like we can't just say, oh, there are positive numbers in those intervals. Well, yeah, sure, there's positive numbers, but there also could be negative numbers. We need to say there are only, you know, like there are only, the derivative is only positive on that interval. So something like that. We want to exclude the idea that there could be negative values for the first derivative on that interval. Okay, great. What about where is f decreasing, Connor? From -2 to 2. And again, the reason there would be because what?
Because values are only negative numbers.
Okay, the values of f prime.
Less than 0.
The values of f prime are less than 0. That's fine. Yes. Again, specify the value. When you just say the values of what? There's lots of numbers up here, so be specific. The values of f prime. Okay. Very good. All right, Anna. Do we have any relative extrema here? Okay. F has a relative maximum at x equals what? Negative 2. How did you know that? Okay, so yes, that's one way to say it. You could also just say, I think even more, another way to say it is you could just say because f prime's changing from positive to negative there. That's another way to say it too. Okay? And then does f have a relative minimum too? Okay. You didn't have to justify any of these. The directions didn't say to. I just kind of gave that example just to kind of, so you can have it. If you want to write the justification down, it's not a bad idea, especially if you think that's something that you struggle with, you need to work on. Absolutely, write it down. The justification here, f has a relative minimum at x equals 2 because what, Anna? How do we know that f has a relative minimum at x equals 2? Okay, because f prime. Be careful just saying f. When you say the function, you're referring back to f then, because f prime is changing from negative to positive at 2. Okay, but again, right thinking there. Just make sure you're precise there. All right. Good. All right, Caleb. Now what?
Find the points of inflection and that has the second derivative equals.
Okay, so what is the second derivative here, Caleb?
F prime equals f prime of x equals
2x. Okay, so kind of like.
x equals 0.
So yeah, so x equals 0. Okay, we don't really call this a critical point. Sometimes I refer to it as a possible point of inflection, but that's a mouthful really, so sometimes I don't know what to call it, but there it is. All right, very good. And so at this point then, Nate, what do we do with that 0? Yeah, put on a number line, that's right. So f prime prime, number line, 0, and then what, Nate?
We substitute in values.
Okay, so pick some values for us.
-1 and 1.
Okay, f prime prime of -1, f prime prime of 1. Okay, when we plug in -1, it'll be -2, so that's a negative value there in that interval, and then 1, positive 2, so it's positive values. Okay, very good, Nate. Thank you, sir. And so then, Mac, how do we interpret this? That's right. Your number's up.
I haven't had like the number 12 in the last 3 years.
It's increasing from,
Okay, careful. We're looking at the second derivative. So the second derivative does not tell us increasing or decreasing. F is concave up, like a cup. Okay, 0 to infinity. And again, if we were to justify that, we would say because what? What told you that, Mac? F prime prime is greater than 0 or positive on that interval. Yep, exactly right. That's the justification. Okay.
and S is concave down
Okay, right.
from negative infinity
Okay, and again, if we were to justify that, it's because
less than,
f prime prime is less than 0. Don't forget, don't just say it is less than 0. Make sure you're saying f prime prime is less than 0. That's what's telling us. And again, that's what we're looking at right here, right? This means negative. So you can just say f prime prime is negative on that interval. Very good. And then Maya, do we have any points of inflection? Okay, so f has a point of inflection at x equals 0. And again, if we were to justify that, Maya, how did you know that? Because what? Beautiful. Excellent. Yes, very good. We're going to use the it's there. No pronouns, right? She changed it back. F prime prime is changing from negative to positive at that point. Okay? And that's it. That's your justification for it, okay? Really easy. Those justifications should be easy points for you, okay? They should be easy points, okay? It's very straightforward. I mean, you're basically just saying, what are you doing, okay? Now, if we look, down here we got two graphs, all right? This, as you can see, it's labeled y, so this is the graph of the function, the original function. This is y prime, so this is the graph of the derivative here. So if we look, okay, here's our original function. It is increasing from negative infinity to negative 2, and from 2 to infinity, decreasing from 2 to infinity, okay? F is, negative 2 to 2, I'm sorry, from negative 2 to 2, sorry. Negative 2 to 2, it's decreasing. Has a relative maximum at x equals negative 2, relative minimum at x equals 2. Concave up from 0 to infinity, right? There's the cup that Mac was talking about. Concave down from negative infinity to 0, there's the frown that Mac was talking about. And then point of inflection at x equals 0, and sure enough, we're changing from concave down to concave up, right at 0 there. That's what Maya pointed out there. Very good. Okay. Again, notice though, if we look at the derivative, right? So let's again match these pieces up. Okay, we said that f was increasing from negative infinity to negative 2, and notice from negative infinity to negative 2, f prime is positive. It's above the x-axis, right? That's what we use. Then at negative 2, the derivative is 0, and at negative 2, we have a horizontal tangent there, right? Slope of 0. And then between negative 2 and 2, f prime is negative, and then between negative 2 and 2, f is decreasing, right? A negative derivative means the original function is decreasing, and then a positive derivative means the function is increasing from 2 to infinity. Okay? It's pretty cool how it's all related like that. Question? Anna? So negative 2 is just a critical point according to this, but because the derivative is changing from positive to negative at that negative 2, that means we have a relative maximum at negative 2 in the original function, right? 2 is a critical number of f, because that's where the derivative equals 0, but because the derivative is changing from negative to positive there, that means in the function it's changing from decreasing to increasing, so relative minimum. And then also, I was telling you guys yesterday, this is the most difficult thing maybe, okay? We can look at this and see, y prime is decreasing on this interval. Therefore, its derivative will be what on this interval?
Negative.
Negative. Since y prime is decreasing, its derivative, y prime prime, will be negative. If y prime prime is negative, what type of concavity does that indicate in the original function?
Down.
Concave down. And sure enough, where we're decreasing from negative infinity to 0, we are concave down from negative infinity to 0 right there. Look at that. Okay? Where we are increasing in the, so where this is increasing, that means its derivative will be what? This is increasing, so its derivative will be positive, and that means the derivative of this thing is y prime prime. So where y prime prime is positive, y will be what?
Concave up.
And there it is, concave up for that interval. Okay? Relative extrema, right? We're changing from decreasing to increasing. So that means in its derivative, it's changing from negative to positive, which means the concavity is changing from concave down to concave up at 0. So a relative extrema in the first derivative indicates a point of inflection here in the original function. Okay? Lots of stuff going on there. That's probably the trickiest stuff, right? Relating the first derivative and the original is pretty easy, but relating the first derivative to then the second derivative back to the original, that's, an extra step in there, and that makes it a little more complicated. That's the idea. Questions on any of that? Okay. Then flip the paper over. Okay, and this is a free response question from an old AP test. And this is not one from like the 70s. This is from a relatively recent one. Okay? So like, here's the enemy, right? Here's what we're going to be like fighting a couple months from now, all right, in the new year. So this is what we need to kind of like be prepared for, okay? But believe it or not, right, we have the capability to basically do an entire free response question.
You gotta kill some jabs, boys.
That's from an AP test. We're going to look at this one.
The AP calculus jabs.
Okay, so let's take a look at this. Let's tackle this. Okay, so we're told here in the directions, it's very important to read all the information that's given to you. It's very rare that you're given information that you aren't going to use here. Okay, so it's very important we read these directions. So 4 says, The figure above shows the graph of f prime. Okay, that's key. It's also labeled right there that this is the graph of f prime. So we got to keep that in our mind. We are not looking at f. This is f prime. Okay, the derivative of the function f on the closed interval from -1 to 5. Okay, so we're looking between -1 and 5 only. We're not told what f actually is. We have all that information there. The graph of f prime has horizontal tangent lines at x equals 1 and x equals 3. So this kind of takes the guesswork out of it. You're like, well, is 1, 0 the, kind of highest point there? Is that a relative max? And yes, it is. There's a horizontal tangent there. There's a horizontal tangent right there. Okay? The function f is twice differentiable with f of 2 equal to 6. So that's also important, right? F is twice differentiable. That means what? F prime exists and f double prime exists as well. It's twice differentiable. So both f prime and f double prime exist and are, continuous and stuff. With f of 2 equal to 6. So that's the only information, explicit information we're given about the function f. At 2, the function is equal to 6. But this, remember, is a graph of f prime. You notice here at 2, the graph is -1 because, again, this is f prime, not f. All right. So, letter A says, to find the x-coordinate of each of the points of inflection of the graph of f, give a reason for your answer. Right, I know there's lots of ofs there. Of the points of inflection of the graph of f. Yeah, 4 ofs. Oh, no. 1, 2, 3, 4, 5 ofs of each of the points of the function. Yeah, so anyway, you get it, okay? So give a reason for your answer. All right. So remember, keeping in mind here, we're looking at f prime. So again, what you should reflect back on is if you want to find, this is where knowing those fundamentals are so important. We want to find points of inflection of f. What do we normally do to find the points of inflection of f? Second derivative, set it equal to 0, and we want to find where the second derivative is changing from negative to positive, positive to negative. Okay? That's what you need to have down in your brains like that, just like what Emma did, okay? Rattled it off, just like that, okay? We also need to also check to make sure the second derivative, set the second derivative equal to undefined as well, right? Not just 0, but undefined for those points. But otherwise, perfect there, Emma, exactly right, okay? All right? So that's what you all should be able to do, rattle that off. So now we look at this. What do I have? I have a graph of f prime. So how can I use f prime? How can we use f prime to then figure out where my second derivative is equal to 0? Let's do that first. So how can I use this graph of f prime to know when f prime prime will equal to 0?
Well, where there's horizontal tangent lines on that graph.
Right, because if we find the horizontal slopes on this graph, that means its derivative, f prime prime, will equal what? 0. And so where do we have horizontal tangents?
X equals 1 and x equals 3.
We're told at x equals 1 and x equals 3. Okay? So those are possible points of inflection then. Okay? So let's check. At x equals 1, okay, we now need to figure out, and I guess we can kind of like do this if we want to just for a little bit of work. All right, so we've got a critical point at 1 and a critical point kind of at 3 there of the second. So these are possible points of inflection. Okay? To the left of 1, so to the left of 1, here's my little graph there to the left of 1. Is my second derivative going to be positive or negative based on what we see here? Okay, so I hear positive. Why? Because f prime is increasing, therefore its derivative, f prime prime, must be positive. Where a function is increasing, its derivative will be positive. Here, in this case, our function is f prime. Its derivative, f prime prime, will be positive there. That's right. Okay? All right, what about between 1 and 3? What behavior do we see here? Decreasing. So therefore, its derivative, f prime prime, will be what? Negative. And then to the right of 3, increasing, so positive. Okay? So, where do we have points of inflection? Yeah. Okay, that's exactly right.
But you don't have to draw that justification for it, correct? Because you can see that on the graph, right?
Right, but I'm doing it just here to have something kind of explicit for us, especially since we're, doing this as like a notes kind of thing, but no, you would not need to. However, we do, so I'm going to write this. F has a point of inflection at x equals 1 and x equals 3 because okay, and our justification here needs to come from the information we're given. So we need to somehow use f prime. Question? No? Okay. So f has a point of inflection at x equals 1, x equals 3 because f prime, what is true about f prime that told us we had a point of inflection there? It's changing from increasing to decreasing, or we can say vice versa. Because f prime is changing from increasing to decreasing, or vice versa at these points. Okay, that's it. That is sufficient. If you want to be a little bit more wordy, you could then say, since f prime is changing from increasing to decreasing, that means f prime prime is changing from positive to negative, and therefore f is changing from concave up to concave down. And then of course vice versa for the other ones.
So vice versa is okay to say?
I think vice versa is okay to say. Yes, my friend was at an AP workshop, and I think he asked, and they said I think vice versa was all right to say. Yes. Okay. Questions on that one?
I'll probably try to avoid sending them the AP test, so I don't
Yes, if you have time, just swap the words around, right? Okay. If you don't have time, use vice versa. If you're hurting for time, just use that. All right. Letter B. And this is okay. This is related to what we've been doing, but it's not exactly, but still we can use that idea. So at what value of x does f attain its absolute minimum value on the closed interval from -1 less than or equal to x less than or equal to 5? Okay? And then we'll ask the further questions later on. But let's just try to figure that out. So we want to figure out at what value of x does f attain its minimum value on the closed interval -1 to 5. Okay, so to determine absolute extrema, what do we consider? Okay, the critical points and the endpoints. Okay, we want to determine the critical points of the function. What are the critical points of f according to this graph?
4, 0.
So 4, 0 is a critical point of f. Why?
Because it's changing from positive to negative, or excuse me, negative to positive.
Sure, and we can also say because the derivative equals 0. F prime equals 0 at this point, so 4 is a critical point of f. Right? Yeah, you've got to be careful what we're looking at here, right? And then what's another critical point that we have here? 1, 0, because f prime is equal to 0. The derivative is 0 at this point. So 1 and 4 are your critical points. So 1 and 4, and then what else?
Endpoints.
And then the endpoints. The endpoints are -1 and 5. So the possible candidates, and again, this is just you don't have to write this work out. I'll scoot it up here in a second, yeah. The candidates then are x equals -1, x equals 1, x equals 4, and x equals 5 for the absolute minimum. Okay, those are the possibilities. Okay. So let's see here. What is f of -1? Right? Don't we normally do that? At this point, now we plug in f of -1. So what is f of -1?
We don't know.
Careful. What's f prime of -1 is -3. What's f of -1? We don't know. We don't know. Okay? So, all right. What's f of 1? We don't know. Okay. What's f of 4 or f of 5? IDK. Yeah, we don't know. In fact, none of us, all of us, DK. All right? So, what are we going to do here? How can we figure out anything?
Put our heads down and
It keeps
cry.
on decreasing until it gets to 4, so it has to be 4.
Oh, okay. Did you guys hear what Caleb just said? What keeps on decreasing until we get to 4? F keeps decreasing until we get to 4. How do you know?
Because it doesn't constantly until
Okay, because f prime is what? Is negative. Guys, look here. F prime is negative for this entire interval, which means that regardless of what the value of f of -1 is, since f prime's negative from -1 to 1 here, right? F prime's negative, that means what is true about f? Decreasing. So if f of -1 is some value, it's going to be a greater value than f of 1 because we're decreasing from -1 to 1, right? We have a negative first derivative, so therefore f is decreasing from -1 to 1. And so f of 1 is certainly going to be less than f of -1, right? Follow that so far? Questions on that? I lose anybody? All right. And so then let's look at the next point, f of 4. Well, f prime is negative for the entire interval there. So therefore, from this point, f of 4 is going to be lower, and from 1, f of 4 is going to be lower. So f of 4 is so far the lowest point. Now, what about f of 5? Why can we throw that one out? Because the derivative is what from 4 to 5? Positive. Therefore, the function will be increasing. So what's got to be the lowest, absolute lowest point? At 4. Now, granted, obviously, 4 is 0 is not the coordinate, but we can say with certainty that f has an absolute minimum at x equals 4. Okay? Now it says to show the analysis that leads to our answer. All right, so I'm going to choose to kind of like write that out.
Would you be able to say like, or could you not be able to say that it's decreasing, f is decreasing until it gets to 4 because it's not technically decreasing at x equals 1?
I'm going to say like f prime is less than or equal to 0 at every point in the interval. I think that should be sufficient. Okay, so f has an absolute minimum at x equals 4 because f prime is less than or equal to 0, okay, from x equals -1 to x equals 4. So, and, oops, I'm not going to finish there. And, okay, f prime is greater than 0 from x equals 4 to x equals 5. All right.
You just do that in interval notation.
Yeah, you can use interval notation, yeah, if you want to. Okay. Okay. Right. Now, the absolute maximum, we can do that one as well. Okay, the absolute maximum value. This one's a little bit trickier to do, so like don't fret too much if like this one doesn't make sense, because it'll make more sense when we see integration later, but we can right now kind of figure it out. The justification we're going to hold off on because it kind of would help if we had integration, but we'll at least kind of like figure this out here. So what are our possible candidates for the absolute maximum?
Only x.
So it could be x equals -1, I would say, and possibly x equals 5. Why not? Why can't it be x equals 1?
Because at that point it's decreasing and then hits a 0 slope and then just keeps decreasing.
Right. So from -1 we decrease, right, because the first derivative is negative. From -1 we decrease to get to 1 in the original function, because the first derivative is negative from -1 to 1. Therefore, the function is decreasing from -1 to 1. So -1 has to be higher than 1 in order to decrease to it. So 1 is right out. Can't be 1. Then we decrease some more, but then we do increase some up to 5. So the question is, are we at a higher point at -1, or with the decreasing and the decreasing and then a little bit the increase here, did that increase us enough to then be higher than -1? And what do you guys think? Yeah, no, it did not. Now, anyone want to try and justify that, son? And Caleb, you want to try and explain it? Or if not, that's fine.
Could you say it decreases just for, I don't think
Okay, that's fine, Brandon, you want to give it a shot, and then we'll go with Ryan?
Yeah, the length of the decreasing portion is greater than the length of the increasing portion.
Okay, and that's about as best we can do. Is that what you want to say too, Ryan? That's about the best we can do right now. Later when we see integration, the actual way that we can determine this has to do with the area underneath the curve. The amount that we're decreasing by is the space between the curve and the axis here. So if you look here, this area right here and this area, that's the negative amount by which we are decreasing. And then this area from between the curve and the axis is the positive amount by which we're increasing. Very clearly here, like geometrically speaking, right, this area overpowers this positive area here. And so therefore we are net decreasing from this point to 5 because that little increase does not cancel out that amount of negative decrease. Okay? Don't worry about that for right now. We'll see that later. But yes, the absolute maximum here would occur. Yes, I'm sorry. F has an absolute maximum at x equals negative 1. Okay, I almost said 5 there. Okay, and again, don't worry about the justification for that right now because, you know, we haven't quite gotten to that point. But you do have an intuition about it, so very good. You guys are able to, you know, intuitively see that. That's good calculus, you know, intuition there. Yeah. Okay. All right, letter C. Now let's tackle this one. So letter C says, let g be the function defined by g of x equals x times f of x. Find an equation for the line tangent to the graph of g at x equals 2. This is also very typical, where, you know, maybe like your A, your B, and your C will all be like kind of related, kind of like in the same vein of questioning, but then like the part D, or whatever like the last letter is, will kind of like make a right turn and ask you a question. You're like, wait a minute, this is like not even related to any of the stuff we just talked about. And in a way, you're right, this is not really related to anything we just talked about, yet we can still use what we've got here to kind of help us. Okay, so, and again, this is where knowing that fundamental idea. So in this case, what are we supposed to do? Find an equation of a tangent line. Now guys, what do we need to write the equation of a tangent line? We need a slope and we need a point. Okay? So, we want to find the line tangent to the graph of G. So to find the slope of G, what do I need to find? The derivative. Okay? Here's G right here. G of x is equal to x times f of x. So I want to find g prime of x. And you might look at this and say, what the heck, there's an f in there. How am I supposed to take the derivative of f when I don't know it? We're not even told what f is. Right. When I take the derivative of x times f of x, what rule are we going to use? It's a product. We're going to use a product rule, okay? So it's the first, x, times the derivative of the second. How do I denote the derivative of f?
F prime.
Yeah, just f prime. Okay, times the derivative of what's inside, but the derivative of what's inside there is just what? The derivative is 1, so we can stop there. Okay, so plus the second, f of x, times the derivative of the first. What's the derivative of x? 1. Okay. And I want to specifically find g prime of what? I want to find the slope at 2. So I'm going to find g prime of 2. All right, so, oh, that's easy. What's x got to be then? 2 times f prime of 2 plus f of 2 times 1. Okay. What the heck is f prime of 2?
Look at the graph.
Look at the graph. That's right. Go back up to the graph here, folks. Look at this. It's given to us. At 2, f prime is negative 1. Okay? Okay, but what's f of 2, though?
6.
Yeah, right. That little piece of a little innocuous piece of information there that we never used for A and B, we completely ignored it. That is why it was given to us. And I told you, it is very rare that you are given a piece of information you won't use. So this piece of information, we ignored it for A, we ignored it for B, but then it shows up right there in C. Okay? So there it is. So what's our slope? It's 4. All right. So we got our slope, but now we need a point. And we specifically need the point where x is 2.
So I guess the original equation.
Yeah, what is f of 2?
It's 2 times f of 2.
It's 6. So our point on f is 2 comma 6. Our slope is 4, and so we just write the equation. Y minus 6 equals 4 times x minus 2. There's the equation of the tangent line. Yep.
Why wouldn't you plug 2 back into the original function of g?
Oh my gosh. Thank you. I'm so sorry. Thank you. Mr. Woodmire made a mistake here. Yes, sorry. We are trying to find the tangent line to the graph of G. So it's G of 2 that we need to find. Thank you, Austin, for saying that, okay?
Yeah.
Yeah. All right, so it's G of 2. G of 2 is going to be then what? 2 times F of 2, but what's F of 2? 6, so it's 2 times 6, which is 12. Thank you. So, yeah, sorry, the point is 2, comma 12, and the slope is 4. So we get y minus 12 equals 4 times x minus 2.
Nice.
Okay, so that's it. Thank you, Austin, for pointing that out.
Another example.
This is f of 2 equals what equals
Another
2 times f of 2 equals 2 times 6 equals 12. How do I know what f of 2 was? It was given to us right up there, Mac. F of 2 is 6.
26.
I'm sorry, it's 2 times 6. Now, let me show you guys something here real quick. We're going to go through this. So this was a question from the 2004, okay, so it's a little over 10 years ago, but these questions are very similar still to what you see now. This is from 2004 scoring guidelines. This is a Form B question, okay? So there's the test that the majority of you guys will be taking is the, I guess we call the Form A test, the normal test, okay? Those of you that, for whatever reason, if you're like sick that day, or like if you like have a bajillion other AP tests that conflict with that, then you'll take the Form B version later, okay? You do not want to take the Form B version. It's weird, okay? They ask different kinds of questions and stuff like that.
It's like their backup questions or something.
It's kind of like the backup questions. Yeah, it's kind of like that for all of them. So please, you know, if you can take it, the normal version, that's what we want to do. Okay. That being said, they're not like completely off, but sometimes it's just like it's just kind of like twisted a little bit from what the normal kind of questions are. So anyway, this is what an actual scoring guideline looks like. When you take your test and you put these answers in your answer book and you submit your answers, they go to some central location, and then where some graders then grade your test. And when they're grading your test, they are looking at something exactly like this. Okay? They look at this, and they have a little rubric here, and then they have their points. So you can see here, right here, okay, you get 1, so it's 2 points for this section, for Part A. You get 1 point for correctly identifying both that x equals 1 and x equals 3 are your critical point, or your points of, your points of inflection there, okay? Notice, you don't have to give a reason, you still get that point, okay? There's no point for work, just showing that x equals 1 and x equals 3, that's enough. So there you go, Austin, you don't have to show any work there, you can just identify it as 1 and 3. And then 1 point for your reason. Again, guys, if it says give a reason, there's a point attached to it. Okay, at least. Bless you. Letter B. Okay, 1, you have to indicate that f decreases, then increases. Okay, we did that. Okay, we did that, right, in our little explanation. We eliminate x equals 5 for the maximum. Okay, so we didn't even include x equals 5. Oh, actually, that was for the absolute. Okay, that was the later thing kind of thing. We identified the correct absolute minimum. We identified the correct absolute maximum. X equals -1. Okay, so there's 4 points possible there. And again, we could at least get 3 without kind of knowing what we need to know for that point for the eliminate x equals 5. And then Part C, you get 2 points for the derivative, and then 1 point for the tangent line equation. Notice, guys, the answer is only 1 point. So if you like mess up that tangent line, like if I had been taking this test, right, I would have lost the point for the tangent line equation because I would have written y minus 6 instead of y minus 12 there. But I still would have gotten 2 points for G prime. If you can pull 6 points out of these questions, so that's 6 out of the 9 points, each one of these has 9 points. If you can pull 6 out of the 9 points, you are on your way to a 5. Okay? If you can pull 6 out of the 9 points here, you are on your way to a 5 on the AP test. Yes.
Really?
6 out of the 9 points. Because if you think about it, what is 6 out of 9? 66.6%. What is the percent you need for a 5? Around a 65, 66%.
That's it?
If you can pull 6 out of the 9 points here, yes, that's it. But you have to keep in mind, right, we were working through it together. So, it's doable, but that's why we have to be so precise here, right? We don't want to lose stupid points for, not giving good justifications. We don't want to lose stupid points for, missing, F prime and saying, it's changing from increasing to decreasing, all right? It's doable, folks, but you gotta be precise.
You get the wrong points for one things, and then you have a justification for those points. Will you get the whole thing wrong, or will you get the justification wrong?
So it's debatable. I would imagine in this case, your justification would have to be wrong as well, though, because you got the wrong points in the first place. You understand what I'm saying? But there are cases where yes, you can get those, those points depending. And the graders will, like, confer on things. Like, they're not just, like, in a little cubicle by themselves grading. They're, like, at a table, and they'll talk and some say, well, should we give a point for this? Should we give a point for this? And they'll ask and stuff.
Are they
so.
nice people?
They're other calculus teachers, so it just depends. Yeah. No, I have not, because it happens, like, towards the end of the school year, like, while we're still in school. And so Mr. Hism, I know, has done that. He took like a week off and just went and did it. I don't want to do that. Oh, that's like a couple of days. Yeah, like you grade for like a whole week, I think.
He graded AP
Do
Chem.
they pay for like your travel and like where you would stay?
Yeah.
Where do you go?
It depends. It changes from year to year, I think, where they located. So.
It's like some black nondescript building. In
Right, exactly.
It's like a CIA black site.
Yeah.
It's like the underground appendix, side R.
You try to find it on Google Earth,
Okay.
and there's like a
It's like a blank spot.
clearly
All right.
photoshopped cloud over it.
We're gonna stop there for now. Okay. What I would like you guys to try for homework, okay, is example 5, which is the next page. Okay, example 5, and I'm also going to pass out a problem set. So just example 5, and I'm going to pass out a problem set as well. Problem set will be due, Tuesday of next week, if you want to do that. Okay?
Alright, so is there any chance of a variation out of the window?